how do we really know if one of the biggest ideas in science is the real deal? Today, we're going to build a new tool for your toolkit, one that'll help you sort the truly powerful theories from what might just be, well, interesting pictures.
I mean, come on, we've all heard these incredible concepts, right? They're super exciting, the stuff of great science fiction. But when they're presented as serious physics, they can sometimes make us completely skip over a much, much more fundamental question.
And this is the core of it, isn't it? Before we can even begin to talk about bending space-time or teleporting across the galaxy, we really need a solid theory for the basic stuff. What is the universe actually made of? And how does it all work, from one moment to the next? This brings us to a concept our source material calls the machinery of reality. Now, this isn't just a description of what we see out there, it's the fundamental engine that actually drives the cosmos. And here's the thing, any theory that doesn't explain this machinery, well, it's missing its most crucial part.
Okay, here's a fantastic way to think about this. Some theories that give you a beautiful, really detailed picture of reality. It looks great, but a true scientific explanation, that needs to give you the engine, the actual working mechanism that makes that pretty picture come to life.
And that's the problem we're talking about today. A lot of popular ideas in physics are basically just these static pictures. They might be mathematically elegant, sure, but they don't give us the engine. They don't explain how reality actually functions. All right, let's look at a real-world example to make this concrete. The idea that reality is discrete, made of tiny, indivisible pixels, like a computer screen, it's a perfect case study of a really intriguing picture that kind of struggles to provide the machinery. So when you start to poke at this pixelated model, you find some pretty big mechanical problems. First, there's causality. If reality is just a series of separate frames, what makes one frame actually cause the next one? Then there's binding. What holds these pixels together so they can interact with each other? And maybe the biggest of all, completeness. A full theory has to describe everything, and that includes the space in between the pixels. And that right there, that gets to the absolute core of the issue. If your model of reality has gaps in it, your explanation just isn't complete. A theory about pixels that can't even describe the space between them isn't a theory of everything, it's just a theory of some things. So you have to wonder, right? If a theory has these kinds of huge mechanical flaws, how does it survive all the scrutiny? Well, sometimes the answer is in the language that's used to defend it. A language that can feel, intentionally evasive.
Think about concepts like hyperspace or teleportation. They're super easy to write down in an equation, mathematically. But the source material argues that a lot of the time, they just can't be realized in reality because no one ever actually proposes the physical machinery for them.
And the argument goes that this isn't just an accident. Using these complex, kind of vague terms can actually be a tactic, a way to deflect the really hard questions about how things actually work, and instead shift the whole conversation away from physical mechanics and into abstract math. In fact, this quote from the source material just sums up that defensive strategy pretty bluntly. It's a method that just shuts down productive scientific debate. It protects an incomplete idea from the tough, necessary questions about its underlying machinery. Okay, so what's the big takeaway from all this? Well, it's that we should feel empowered to ask for more. We should actually demand full explanations that go way beyond just a cool-looking picture. Just remember that core idea. An interesting picture is never enough. A really robust scientific theory has to provide the engine, the actual nuts and bolts of how reality works. This is the standard we should hold these ideas to. A great theory doesn't leave us with a bunch of mysteries disguised as answers. No, it gives us a complete and coherent mechanism that explains why things go the way they go. So the next time you come across some grand new theory about the universe, you'll have this tool. By all means, appreciate the beautiful picture it might be painting. But please, don't forget to ask the most important question of all. Okay, but what's the machinery?